Good afternoon,
Ready.
everyone. I'm Ephraim, and my co-fellow is Stephen.
And we will be presenting our capstone project about malware prediction. Um, are you are you currently working at home or maybe having your classes on the internet?
Or maybe ordering food online, or shopping online, or even dating online. Now, everything is held online.
This COVID pandemic situation accelerated the transition of this era into a pure digital one.
As we begin to rely more on the internet and to counter the effects of COVID-19 outbreak, its benefit is undeniable. However, online isn't safe when malware can infect us. But what are malwares anyway?
Malware is the short term for malicious software.
In layman's term, malware is to computer as COVID is to humans.
On May 2017, WannaCry ransomware infected around 300,000 PCs in 150 countries. This resulted to an estimated of $4 billion of losses, as you can see here in the picture.
Also, it disrupted 40% of the healthcare organization worldwide. Imagine if there's a malware outbreak right now, our healthcare system will be overburdened. In effect, millions of lives will likely be lost.
Now, we've created a word cloud based on our scraped Twitter sentiments. We use a scraping tool called Twint, and we use it to collect thousands of tweets of related tweets such as viruses, worms, trojans, spywares, and ransomwares. As you can see here in our word cloud, uh, these are the terms associated with malwares on Twitter. And now we know that malwares are very serious and very common.
As you can see here, these are examples of our scraped Twitter sentiment. One demanded ransom for 4.9 million US dollars. Seeing its effects, we need to protect our work, our business, and our personal data and be aware of what's going to happen if we don't protect our computers. Now we know that malware is a very serious problem. Our objective is to find out if we could predict if our computers will be affected by these malwares. We plan to do this by using the data from Kaggle competition that was started by Microsoft. And we built a machine learning model in order to try to predict these infections.
So here's the summary of our workflow. So first we did a data cleaning and pre-processing, and then exploratory data analysis, model tuning, and then we'll wrap it up with our limitations and recommendations. So for our data cleaning and pre-processing, um, first is we load the dataset that we got from Kaggle, which is the Microsoft Malware Prediction dataset. The dataset consists of 8.9 million rows and 83 columns. Second is we reduce the memory usage and deleted unused variables to reclaim more memory. These actions were performed in order for our computers to prevent from crashing.
Third, we remove the unnecessary columns, which are columns that have more than 40% of missing values, columns we deemed as redundant, and columns that we believe are insignificant. Also, individual inspection of these common columns were done in order to clean the data. For the remaining columns that still have missing values, we imputed it according to this methodology. Categorical features, we used mode. For numeric features without outliers, we used the mean. For numeric features with outliers, we used median. After that, we encoded categorical columns. All this pre-processing resulted to a total of 116 columns. And then, for the exploratory data analysis and visualization, we retained the same number of rows, and for modeling, we sampled 1 million rows for training.
Thank you, F. So for our exploratory data analysis and visualization, we found out that most of the data are fairly balanced and the target variables are equally distributed to subclusters. So here's our featured column. The first one is AV products installed. You can see in the chart that the x-axis label is the number of antivirus program installed, while on the y-axis label is the number of rows that has detections or not. We can see that the number of detections on a single antivirus program is higher than machines which have two or more antivirus programs installed. It means having more antivirus programs means that the detection of the system is lower.
Antivirus product states identifier, or specific ID for specific configuration of user's antivirus software. Some configuration sets are prone to malware infection, thus configuration matters. However, for these are configuration ID. The specifics of what configuration was up or not is unknown to us. Here are the results of our models. We used four ensemble-based machine classifiers, which are like GBM, AdaBoost, Random Forest, Extra Trees. We use these ensemble models due to the fact that most of our data are categorical features. Like GBM outperformed these other models. And these models correctly predicts whether machines have malware 65% of the time.
So upon plotting out our feature importance, here are the top 10 factors that mainly contributed to the prediction of our models. We can see here that the main contributing factors are the first ID for the specific configuration of a user's antivirus software and the version of the antivirus, meaning that we can assume that the updated version also played a main role in the detection rate, and then signature database version also played a huge factor in the model of performance. And lastly, the rest of the top 10 important features consisted of features derived from Windows OS build version and the identification for the country that the machine is located in. And now for our limitations and recommendations, we base it on our feature importance. As you can see here, the first is you need to install a trusted antivirus of your choice, or you can also use the default Windows Defender to protect your system from malwares. We recommend for personal use using the default Windows Defender. And as for businesses, you may need to use enterprise level of security like Windows Advanced Threat Protection Program or like McAfee Endpoint Security or and others. And the second one is to update your antivirus version and your signature database version. It is very important to constantly update the antivirus software on your computer because computers are regularly threatened by new viruses and malwares. And the third one is you update your Windows OS version. It is also important to keep your Windows OS version updated regularly because Windows updates consists of improvements and patches to fix the issues of certain computers. And last, smart screen and requiring the admin policy. Smart screen and requiring the security administrator's approval before running unknown software will prevent users from executing potentially malicious programs.
For the limitations, infection does not equate to detection. Not all viruses can be detected by the antivirus software. There is a possibility that bias are on the dataset because there might be cases that software didn't flag the specific virus. Al- Also, because dataset doesn't contain time-related column, we were not able to conduct time series analysis. Also, we only used 1 million rows of data from the original 8.9 million in order to reduce memory usage for us to be able to train our models.
Um, Thank you. We hope that you enjoyed and learned a lot from us. Once again, we are Quarantine. Thank you guys for listening. For our GitHub link, just scan the QR code below.